some of you in the audience know me and the group that I work in at the University of Queensland, the Centre for Hypersonics, and we've done hypersonic research for over 30 years. We have a ground test facility that's done more tests, hypersonic tests, than any other in the world. And the thing that we do is develop these hypersonic engines called scramjets. And the thing about our scramjets now is they've developed to the point where they're actually useful as part of a space launch system. And so over the last couple of years, we've done a lot of work thinking about how best to do that and how best to use this world-leading technology that we have to enable a small satellite launch capability in Australia. And the key thing is, a scramjet can replace a rocket and can be reusable. So the vehicle there that you can see in the slide is reusable. So we all know about the commercial opportunity for small satellite launch. Maybe not CubeSat launch, but payloads of the order of 50 kilos, 70 kilos, 100 kilos. There's a large market out there for that, and there are a large number of small companies and bigger companies that are trying to meet this demand to enable dedicated launch of small satellites. And at the moment, there is no ability to do that. All small satellites, not just CubeSats, but all smaller satellites at the moment basically tag along with a bigger launch and get tossed out the side and then have to do their business. But as we go forward, there are, as I say, are companies out there developing pretty standard rocket launch systems to supply dedicated launch of the order of 100 kilograms up to 300 kilograms. And so our plan is to make use of our scramjet technology in order to do that, but to do it in a reusable way. So to not toss the rocket away every time, but use a scramjet, which is essentially a hypersonic aircraft, to launch a small satellite. And so it's a real commercial opportunity for Australia. And you can imagine, if you don't have to throw your launch system away every time you use it, you're probably going to be able to do it cheaper than the opposition. And so that's the idea. So this is just some market research that's been done. It's slightly out of date now. It was done in 2014, about how many launches are there. So this is a list of the number of launches up to 50 kilograms on the vertical axis. Horizontal axis is the year. And there are some projections towards 2020 of the order of 500 different payloads. Now, that projection is based on there not being any dedicated launch. And as we all know, these small systems, small satellites such as these, have to tag along with the bigger system. And interestingly enough, they still pay, or you will still pay, if you plan to do it, a hell of a lot of money per kilogram to tag along with someone else's launch. So the current prices right now to sun-synchronous orbit for something of the order of 100 kilograms is $5.95 million US dollars. So that's very close to $60,000 a kilogram to sun-synchronous orbit. With our reusable system, we've done a lot of business modelling. So this is not just a university effort. This is an effort with some small companies, Australian companies. We believe with a reusable system we can supply a dedicated launch for the order of $25,000 per kilogram US. So less than half that sort of price. So this is the type of system that I'm talking about. It's actually a three-stage system, just like any other rocket launch system. The first stage is a rocket booster, a scramjet. Its main limitation, and the reason that you don't see scramjets flying around that right now, is that don't generate any thrust until you get to Mach 5. Okay, so from takeoff to Mach 5, a scramjet is no use to you. So you need a first stage to get you up there. And our plan is to have a reusable first stage you know, using the ideas that Elon Musk and SpaceX have put forward, but doing it in a much simpler way, using aircraft technology. Our solution is not a rocket solution, our solution is an aircraft-based solution. And I'll show you a bit more detail on that. So that's the first stage. The second stage is our scramjet vehicle. Hypersonic vehicle goes from Mach 5 to Mach 10, totally reusable. And then we have a very small upper stage which is expendable. And if you do the mass budget on this thing, 90% of our mass is reusable. So 90% of our system comes back to land beside the launch pad, essentially, not downrange in the ocean, but right beside the launch pad. So this is the idea. And the other thing about this system is it's quite small. It's not a SpaceX level system. I don't know if anyone's been to Los Angeles, but Elon Musk has one of his reusable boosters in his car park. Have you seen that? Mm-hmm. Absolutely amazing. But the thing is massive. It's like 50 meters high and 5 meters in diameter. That thing that you see landing on all those videos, it looks like a video game. That is absolutely massive. This is not what we're talking about here in Australia. We're talking about a small system of the size of half the size of a 737. So it's a tiny system. And this is how it would work. So it's vertical launch. The rocket boosters get the scramjet up to the takeover speed. They then separate, re-enter, and deploy wings and a propeller. And it all seems very exotic and perhaps complex, but the thing about a rocket booster is once it's expended its propellant, it's actually a big cigar case. It's very, very light. It doesn't need a lot of lift or a lot of propulsion to bring it back to base. So it's an aero solution to this problem of reusing rockets, whereas the SpaceX solution is a rocket-based solution. The second stage then accelerates onwards and upwards up to Mach 10. That vehicle needs to be made out of high-temperature composite materials, which we've done a serious amount of work on here and in Germany over the last couple of years. Once the scramjet vehicle has finished its job, it can then fly back to base as well. So all those things come back to base. They can be refueled and used the following week. And then the upper stage goes up to sun synchronous and releases the satellite. So that's the system. And so it's following on from the ideas of SpaceX about reusing, but in a much more practical and I think commercial way. We're bringing things all the way back to base, and we're using aerodynamics to do it. Okay, so just a few details. So we actually have flown a scale version of that flyback booster. We did that in 2015. It's a pretty ugly aircraft from an aircraft perspective, but it's basically a big can. And it's very restrictive on how big a wing you can put on. It's a very ugly aircraft, but it actually flies quite nicely and can be controlled, no problem. We've been working with a small startup company on this. This is not a university thing. This is a UAV company. We went to them and they got really excited, and they've done a really lovely job on the subscale version of this. There's obviously a lot of work still to do, but it was just great to see that it could actually fly. The UQ part, the hypersonic scramjet vehicle, has 4 scramjet engines on it. As I say, this vehicle, it's way, way smaller than the 737 that I came down from Brisbane this morning on. Needs the boost to Mach 5. And once it's done its job, it's a high LOD vehicle, so it can just turn around and come back to land. Right, so fully reusable. And we're following on from these ideas that SpaceX have pioneered, but we're using our knowledge, our world-leading knowledge in scramjets, to find our place in this new burgeoning market for small satellites. Okay, so where will we launch from? So, we're at University of Queensland. You can actually launch north to sun synchronous orbit or polar orbit from the Queensland coast. You could also do it from South Australia south as well. But the key thing is, from a business development perspective, we want to be in a place where people want to live, but it needs to be in a regional area as well. So it's a good combination of things there. And so that's just one possibility, a place called Harvey Bay, which is actually a very popular place for whale watching. So you can watch whales during the afternoon, then you can go and watch a space launch in the evening. So so who else is in this market, right? So when we talk to investors, we have to be clear about this. And so there are actually two players, serious players in this market. There are a lot of other people that talk about it, but there's Virgin Orbit, which is now a spin-off from Virgin Galactic, and there's Rocket Lab in New Zealand. And this was a lovely picture. This is not my picture. This is from The Economist magazine, so I should say that in case they get upset with me. But it's just such a lovely picture, and it shows the scale of everything that we're talking about and what these other players are doing. So here is the Electron, which is the Rocket Lab rocket, and the Virgin group are actually doing an air launch. So they're actually going to operate a 747, which has to have pilots on it. Then they're going to do a rocket launch, and then they're going to throw away the rocket. I would invest in that. They're going to lose money, hand over fist. They do have a lot of people signed up to them. Rocket Lab have a more standard system. It's just a standard rocket launch, small scale. They don't have too many customers that they've listed on their site, but it's very interesting to see, look at the prices here. These are basically the same prices as an undedicated launch that's available right now. Now our system is about that scale. So because it's sort of an aero-based system, it's actually slightly bigger than the smaller rockets. But as I say, the whole system's reusable. So we have a team together right now where we're taking this technology out of the university. The university is not the place to develop technology, it's a place to do science and research. And so we're in the process of taking this outside the university with some private companies. We're working also with a group in Germany with the composite materials. UQ is still supplying this core scramjet technology. And then we're also working with government. We're a part of the HiFi program, which is a scramjet launch program. And and we're talking to governments as well about how this would be done. So we're putting a bit of a team together. We have been over the last 5 years. And so the takeaway from this is, that there's no reason why Australia could not have its own indigenous launch capability. And we have some key technologies and niche areas that can be applied to this. And it's really just a matter of having a go at it. And so, this audience is perhaps the customers that could use this facility. And so I'm very interested in hearing your thoughts on what you might think in the future that a system like this could do. So thanks very much.
Thank you very much. Any questions? I'll start with the back.
Yes, Ross, yeah.
Michael, I was just wondering, the aerodynamic stability of the whole launch stack. At first, the centre of gravity is going to be way down. It's going to be a very difficult to control vehicle.
Are you in the vertical phase?
Yeah.
Yes, so it's all controlled by a thrust vector control system, just like a very typical rocket. There's more lift there in this system. There's some aero work that needs to be done, but with modern control software, we're expecting that it can be managed.
Well, the question was, when do you think it might be available? You do have some competitors out there.
We do.
Obviously, this is good thinking, but...
Yeah, well, so we're talking to the investment community at the moment. We're also talking to government about getting behind it. But our competitors are ahead of us. But the key differentiation for us is reusability. They're basically using pretty standard technology, shrinking it down, and they're going to launch a rocket and throw it away for $6 million. And I think you're going to struggle to make money doing that. I think the only way to make money in the small launch market is going to be reusable, and maybe there are many, many other ways you could go reusable. But this is the way that uses some core technology we have in Australia, which is the Scramjet, which no one else has that. So that's the rationale behind it. But yeah, so you asked me how long? We've done some planning. We think if we started now commercially, 7 years from now we could be doing commercial launches. And if anyone wants to talk to me about that possibility, we do have some, we do have some business cases behind that as well. This is not just a university project anymore. Yeah.
How many times are you going to reuse the first and second stages?
10 times. Or minimum of 10 times. The interesting thing about the Scramjet is, if you can use it 10 times, you can probably use it 20 times. Because, it's not, the failure mode is not really a fatigue. Yeah, the failure mode, if you can design something to last 10 times, you can probably do it for 20 as well. But all our business modelling is based on reusing 10 times.
So final quick question at the back.
Yeah.
So, what is the advantage of using Scramjet in the second stage as opposed to a flyback rocket? And does that advantage outweigh the risk of using a less proven technology?
Yeah. So the advantage is that it can fly all the way back to base with no propulsion. Rocket-based. So a rocket-based second stage would have to have. Well, you could do something like what. SpaceX are not reusing their second stage, right? They're reusing their first stage. But you could try to do something like that as well. You'd have to have extra thermal protection system and all sorts of other things. You also have to have propulsion coming back. The advantage of this is it's a high lift to drag vehicle and it can actually glide all its way back with no propulsion.